Welcome to today's lecture with a new topic. Today's topic is principles and methods of dehydration of milk, that is about drying of milk. So whenever the milk is surplus, it can be dried and stored easily and it can be used when there is scarcity. That's the basic philosophy for dehydration or drying of milk. Here we will discuss about the objective and purpose and uses of dried milk and different methods. Especially in details we will discuss about the drum drying or roller drying, and after that we will discuss more details about the spray drying, that is the modern method. There are different aspects in spray drying, principles, methods, and finally we will discuss about the standards and composition and storage and packaging of dried milk. Here first we will discuss about the objective or purpose of drying milk. Firstly, to reduce bulk, saving storage space and packaging cost. As I mentioned, whenever there is surplus milk, it is difficult to store. So it can be easily done by drying so that the volume is reduced and less space is required, or storage is easy and packaging is easy. Secondly, to improve keeping quality. Especially in case of skim milk powder, it will not have fat, so it can be stored for 2 years, whereas whole milk powder, that will have total fat, so it will have a less storage, that is about 6 months. Thirdly, to reduce cost of transportation. So if the raw milk or normal liquid milk we have to transport, it's a huge volume, whereas after drying it's very less, so it can be easily transported and cost will be reduced. Next is for future use whenever required for other foods. So normally we have discussed earlier that different season of the year milk production fluctuates. So during the dry season there will be less production. So at that time we can make the requirements by reconstituting the dehydrated milk. And finally, handling of excess milk during flush season. I have already mentioned, that is whenever there is surplus production, that milk can be easily handled, stored or transported after dehydration. Here we will see about the use of milk powder. The dehydration or drying of milk means it is finally made into powder and stored. So it has got many uses, like for toned and recombined milk. When we want to reduce the fat content, so we can use this powder with water or recombine it with water for ice cream, for cultured milk, for tea, coffee, during shortage of milk, in candy and chocolate, in bread, biscuit or bakery products. Nowadays the milk powder is used in Indian sweets and for baby food. This nowadays the mostly babies are fed with the reconstituted milk, so this is a fortified with many other nutrients, so in such case milk powder is easily used. Here we will learn the milk drying systems or methods of milk drying. Firstly, we can see it can be done with heating or cooling or cold application. In case of cold, there is a old method of freezing out water and centrifuge, which is not very convenient or practical in modern days, whereas the best method is freezing and sublimation. So this is also called freeze drying. So here the first, any material or milk, it should be frozen and then it will be subjected to vacuum, and at a lower temperature water will be removed by direct sublimation. So from the frozen state, that is the solid state of water, it will directly go to vapor phase without going to the liquid. So that makes a very high quality powder. So though it is not commercially used, but it is used for many other high quality product preparation or biological purpose. On the other side, the heating method of making powder or drying, there are basically two methods. One is film or roller or drum drying. This can be done by two way, by normal atmospheric pressure or under vacuum. So here the round drums or rollers are used. Over this partially evaporated, little bit condensed, that milk you will be sprayed over the drum on as a thick layer, and then it will dry. Inside the drum there will be heating arrangement and it will dry and come out as a scraps. The other method is the spray drying, where the milk is sprayed in a fine particle. So that is called atomization. It is going to be discussed more details. So it has got three different approach. One is by compressed pressure, another is by pressure spray, another is centrifugal disc. So all these things we are going to discuss slowly. Now briefly we will discuss about cold drying, in which the old method which is obsolete, that is the freezing out. We will not discuss much on it. The other method is freeze drying. As I have already mentioned, the freezing the milk, then heating and moisture removed by sublimation without passing through liquid phase under vacuum. So this needs a very high quality machineries, where the milk has to be first frozen, then it will be kept under vacuum, and the lower temperature around 60 to 70 degrees Celsius, the moisture will be removed. It will be very fast due to that vacuum, and it will have minimum heat effect on the product. So naturally the product or the powder which will be made by this freeze drying will have very high quality. It will have very easy and maximum solubility, very high solubility. So that's a high quality product which is more used for making any biological products, especially all kind of vaccines which are available as powder. They are made by freeze drying. Here we will learn about the merits or advantage of freeze drying. So this can be continuous, no presence of air during drying, very low level of moisture. So we can dry it very high, so that very little moisture up to 2% can be dried, and it has got minimum effect on protein and other properties like solubility, etc., which I have already mentioned. So it's a best method, but the demerit is it is a big plant, complicated with a costly machineries and operation cost. Altogether it's more costly. So it is suitable for such products which needs very high quality, like all biological products as powder. The second method for drying is the roller or drum drying system. This is also a little bit old and not so good method. Here the principle is the concentrated milk is applied as thin film upon the smooth surface of continuously rotating steam heated metal drum, roller or cylinder. So in the diagram we can see there is a drum. Inside that there is heating and steam that gives the temperature, and outside a thick layer of concentrated milk is applied. Either it will be falling from the top or it will take the layer by dipping at the bottom. Later the dried film of milk is continuously scraped off by scraper located opposite to the point of application. So where it is done the application, in the other side there will be scraper. So by the time it comes one round, it get fully dried due to the heat inside, and then it is scraped with some kind of knife. Then the dried film is later ground to powder. So this is the very basic principle for drum drying, which we will discuss little more later. Now we will discuss about the advantages and disadvantages of drum drying. So firstly, the advantage is it is a low capital and operating cost. The plant is immovable, takes less floor space and easy to handle. It is suitable for small quantities, and it is powders have better keeping quality due to the direct heating. The disadvantage is the powders have low solubility. Because of the heating effect, it will impact the quality, some kind of impact on the protein and denaturation. So it reduces the solubility. Even we cannot dry it so much, or to reduce the moisture to a very low level. And next is cooked or scorched flavor. Due to the heating and direct heat effect, there is a cooking impact, and that gives a cooked flavor. Here we will see the classification of drum dryer. One is it can be single drum or double drum or twin. The other is they can be under normal atmospheric pressure, or they can be under a closed chamber under vacuum. These are the two varieties we can have. In the diagram we can see that double drum is there, and here we can see from the top that orange color, a partially condensed milk, that is the solid content is little bit increased by evaporation, then that will be falling from the top, and when the drums are rotating opposite direction, because when we have two drum, it will rotate in opposite direction. So when the drums rotates, it takes a thin layer of milk, and due to the heating from inside, it starts evaporation and get dried. By the time it reaches one round, there are scraping knife. So both side we can see, and then after scraping, those dried pieces will fall down, and then again a new layer is formed. So this is how the drums will rotate in opposite direction. There is a falling film, it is called. Whereas in the previous diagram we have seen that is a single drum where the layer is formed by dipping. At the bottom there is milk, and when it is rotating, every time it takes a dip and make a layer, and then it goes up, dried and scrapped. That is the single drum system. Here we can see the flow diagram of operation in drum drying. The first, there is a partial evaporation and milk concentrate is prepared, then adjustable pump, then feeding over the drum, then drying, then scrapping, then grinder it goes, and then there is sifter and dried product. In the diagram, once again we can see there is two drum, they are rotating opposite to each other, and there is a feeding either from the top or it can be from the bottom by dipping, and then once it rotates, by the process of heating, it get dried by evaporation, and in both sides there is knife which scraped it out, and it is being received, and then it goes through a conveyor. There will be grinding. So this is the process of drum drying. Here we can see little more details about the drums and their detail operation. So firstly, the length can be 3 to 12 feet, and the diameter can be 2 to 6 feet. So if it is 3 feet length, maybe maximum it can be 2 feet diameter. Then it is heated internally by steam. So steam supply will be there inside the drum, that gives the heating, and that's the source of drying. It may be at atmospheric pressure or at vacuum, that is 70 centimeter mercury. For better quality, the vacuum plays an important role. Then the heat effect or denaturation will be less, the drying efficiency will be better, and the properties or solubilities will be better. The speed around 14 to 19 RPM, that is the rotation per minute. In 1 minute, 14 to 19 rotation. And the contact period, that is a thick layer of film, once it is touching the drum, it can be there up to 3 seconds. Within this 3 seconds, there will be evaporation and drying will happen, because it's a very thin layer and the temperature will be high. So it takes around 3/4 of the revolution. Here once again we can see the sequence of operation in drum drying. First the lifting of the knives, then starting drums, then turning on the steam, and then placing the milk. Of course, before that the partially evaporated milk should be ready. So this is the sequence of operation which I have explained earlier also. Here once again we can see the diagram which I have explained earlier. This is a double drum. So both sides we can see the scrapping arrangement and collection of the dried scraps, and then it goes for drying, and in the center where the both drum touching, there will be a very thin gap. At this point only partially evaporated milk will be falling, and it makes a film, falling film type. Sometime we can have a milk at the bottom in the tray like mechanism, and there it will dip and take a thin layer. This is how it works. Here we will discuss the important operating points in case of drum drying. We can say these are the factors from drum dryers also. Firstly, close control of the temperature and time of drying. So perfect control should be there on time and temperature. Then evenness of heating over the drum surface. The entire surface should have even heating. Then accurate alignment of rollers. So two drums should be aligned perfectly. The one end to other end, the gap should be perfect and same and uniform. Accurate control of the feeding device. So feeding is very important. There should be perfect control, as a thin layer of milk has to be applied. Preheating of milk before drying. So the milk which is going for drying, it should be already heated at least 40 to 50 degrees Celsius. That helps in quick evaporation and drying. Keeping the drum surface smooth. The surface should be perfect, and that depends also on the knife. So scrapers should be very sharp, and when a layer is coming after drying, it should be perfectly scraped off. using fresh sweet milk. So normally we should use the fresh milk, not any soured milk. And using pre-condensed milk, I have mentioned the partially it has to be condensed, then only it will be easy to dry very quickly. Now we will discuss about the spray drying system, which is a large scale industrial plant for large scale drying of milk. So here the principle is atomizing the preheated and concentrated milk to form a spray of very minute droplets which are directed into a large drying chamber with a current of hot air. Because of large surface area, the milk dry to fine powder instantaneously. So first the milk is partially evaporated, then it is created into a atom like very small particles, and that is exposed to very high temperature in a drying chamber where it dries immediately and becomes a dry particle. The advantage here is the better appearance, flavor and solubility. The quality and properties of the powder will be better. It is most economical since we make it in a large scale in a bigger plant. The disadvantage is the large capital investment. The initial capital investment is very high. It is complicated and cost of operations. So this is, we are going to discuss more details step by step now. Here we can see the combined flow diagram for drum drying and spray drying. At the left side we can see the basic operations, the milk, clarification, standardization, pasteurization and evaporation. After that we get a concentrated milk with 30% total solid, and from there it goes to roller dryer and then milling, sieving and packaging. And the other side for spray drying, it needs little more evaporation with 45 to 55% total solid. Then it goes to spray dryer and get exposed to hot air where it get dried. Then there is cooling air, and then through a cyclone the air is separated, and then the powder is collected and packaging is done. So we will discuss more details about the spray drying next. Now we will discuss about atomization. In spray drying, one of the most important thing is atomization, that is like to make the milk into very fine droplets like atoms. So here to reduce the milk particle in such a small size that it becomes very quickly ready to dry. The remaining moisture in a small particle dries out or evaporates very quickly, and since the entire milk is fragmented into very fine particles, so the surface becomes very high, so the drying becomes very easy and fast. So after this fogging or spraying, it is directly exposed to very high temperature at a drying chamber, which we are going to see next. So it provides superior instantizing, less product loss, less over and under drying. So there will be uniform drying and then more efficient drying. Now we will discuss about methods of atomization. There are three methods. The first one is pressure spray jet, which will have 1,500 to 5,000 pounds per square inch. Here the milk is forced under high pressure through a small orifice and is atomized instantly. So milk is passed through a very small orifice under high pressure. Because of that, the very fine particles are created like spray. And higher the pressure or smaller the orifice, finer is the particle. When the particle is very fine, then it gets dried very quickly when it is exposed to a high temperature. You can see in the diagram, the feeding is done through the atomizer and the high temperature is put inside at around 160 180 degrees Celsius, and the fine particle immediately lose the moisture and falls as a powder. The other two methods, one is centrifugal disc. So here the high speed centrifugal disc creates the spray. The milk is fragmented through this disc and it creates the fine droplets. And the third method is compressed air. Here a jet of high compressed air moves at right high velocity through a stream of preheated milk at a right angle and atomizing the milk instantly. So a high pressure air is hitting the milk flow in right angle and fragmenting it into very fine particles. So that's another kind of atomization. So we have seen three different methods for atomization of milk, and after that it is falling into the heating chamber where instantly it will lose the moisture and becomes a particle. Here in this diagram we can see the process flow. At the top center there is the liquid milk feeding, and then it is undergoing the atomization where the spray air contact area is there, and then there is a air heater at the middle. We can see the air is heated through this and injected inside the drying chamber. It will be 160 to 180 degrees Celsius. Then those small particles get dried and that will fall, and there is a separation, slowly goes down, and then it will go along with the air out, and there is a cyclone separator where air is separated and the particles are collected. There are another additional system for filter bag collector. So we are going to see several diagrams to highlight the different aspect of this process. Here we can see a more simplified diagram. At the left we can see the milk which is being pumped to the atomizer, and that fine spray is getting dried in the chamber. And in the chamber we can see from the top right there is a air heating system from which the air is coming, and then bottom, after drying, the product is going out and then it is going to a cyclone separator. In the bottom we can also see that after drying the air becomes cool, that air goes out and that is used in the cyclone separator to separate the fine powders and the air. So sometimes there is an additional setup that is called filter bag collector, because some of the fine particles cannot be easily separated from the air. So the whole air is injected into the filter bag, that is the cotton bag. Slowly from there the air will go and the powders are collected. Here we can see another diagram. It is highlighting different other aspect, like we can see the concentrated product going to the top, and side by side there is the atomizer and the inlet of hot air. Then we can see the spray chamber and drying chamber. Here at the bottom we can see the inlet of warm air and the outlet of cold air. We can also see the cyclone and then the filter bag collector. From the cyclone, major powder is collected and the remaining air going through the bag filter where some of the fine powders are collected. Here once again we can see another diagram. Here it highlights about the co-current flow spray drying. Co-current means the flow of the air and flow of the milk is in the same direction. We can see the raw milk going to the top and getting atomized and spray like, and the air is coming after heating. Then there is drying is happening. Actually the powders are collected in three steps. In the first step is from the chamber itself. At the bottom a much amount of powder is collected. Then the remaining powder along with air goes to the cyclone separator. There again a much of the powder is collected at the bottom, but still some fine particles remains with the air. That goes to the filter bag collector or dusting bag. There the last part of the powders are collected. Here once again we will discuss about the actual drying mechanism. As I have mentioned, the atomizer makes fine droplets from concentrated milk and put into drying chamber, through which hot air flows co-currently with the milk spray. The inlet air temperature remains up to 180 to 190 degrees Celsius. The milk droplet lose water. The latent heat of evaporation continuously cools their surface, so the temperature never exceeds 75 degrees Celsius for the actual particle. So due to the exposure to high temperature and very fine size of the droplet, instantly it loses the moisture and it becomes a dry. So this is called instantaneous drying. In continuation about the drying mechanism, the whole operation adjusted in such a way that total exposure will be 25 seconds. Most of the milk powder settles in the chamber by means of a stream of cooling air. So the bottom of the chamber, the major particle, larger size will settle, and this milk powder is discharged from the bottom. It goes out and goes to the packaging unit. Only the remaining some part goes to the cyclone separator. Here a little bit we will discuss about the heating air. So there are air filter and there are different kind of spray, water spray type or oil filter type, because this air should not carry any contamination or pathogens. And then there is air intake fan and there is air heater. After that this air goes to the drying chamber. At that time the temperature will be very high. Then in the drying chamber, about it can be rectangular or horizontal, and preferably it will be vertical or cylindrical. So there are different dimensions as per the capacity. We can have different dimension and their diameter or length, etc. That depends more details about the operation in the industry. Here we will discuss about the recovery of the fine particles. As I have mentioned, in the drying chamber, immediately after drying, the particles will fall down, particularly the heavy particles, that is taken out through that, but much of them will remain with the air. So that air is taken to a cyclone separator, which works with the principle of centrifugal force. So here what happens, within the cyclone separator a whirlwind is created, and that creates a outward centrifugal force. Because of this force, the particles having more density than the air, it goes toward the periphery and it attaches to the side of the cyclone separator, and slowly it falls by gravity. So these particle size can be 10 to 200 micron. So they are separated from the air. But there can be some more finer particle which won't get separated. They will be carried to the next phase in the filter bag collector. Here we once again will discuss about the product recovery or powder recovery. So one of the mechanism here is separation of air and powder, that is done in the cyclone separator. Whereas inside the drying chamber also the larger particles has to be taken down, for which there are certain mechanical devices, and there are sometimes airbrush or mechanical sweeper and screw conveyor with gravity system. So through some mechanical sweeper or brush, the powders will be taken down continuously and then it will be conveyed through gravity system. So once again we will discuss about the recovery of fines, that is the fine powders. As I mentioned, the bigger particles will fall down in the drying chamber itself, whereas the finer particles goes with air, and first there is a separation in the cyclone separator and still finer particles will remain with the air. They are collected through the filter bag collector or liquid dust collector. Now the efficiency of this system, particularly cyclone separator, depends on diameter of cyclones. If the diameter is more, then the centrifugal force will be more, so the efficiency will be better. Similarly, mass of particles. If the particles are bigger, the effect of centrifugal force will be more and they get separated towards the periphery and falls downwards. Whereas if they are very fine, they won't be separated and they are taken to the next stage. Similarly, the air velocity. The velocity is created inside the cyclone separator and that makes the centrifugal force and separation. Now this is another important aspect, that is the cooling the powder. Once the drying happens, the major part coming out from the drying chamber through the bottom exit, that should be cooled immediately. Generally the dried product should be removed as soon as possible to protect the heat damage which affect the flavor, color and keeping quality and also the other properties, and most important is solubility. So after drying, that hot powder should be taken out and cooled immediately. This cooling outside the dryer may be done by conduction, that is a method of heat exchange, or by convection, or by cold surrounding the outlet. So different options are available for cooling the powder after separation. Here we can see the another way of flow of operation in the spray drying. We can see from the top there is air is coming, then filter, then heating, and then it is going to the atomizer. And from the left side we can see the concentrated milk with the adjustable pump reaching to the atomizer, and then it is being sprayed into the drying chamber, and after drying it is going out as product. Whereas the air which is coming through atomizer, then it goes through exhaust air fan. It loses the heat, goes through exhaust air fan, then exhaust air hood, and finally it is the outlet air. Here we can see some of the operation technique and principle to decrease the air quantity and thermal loss. So this is how we can best use the energy, that is the heat used in the whole process. Firstly, the temperature of inlet air should be high. Then only there will be very fast drying. Secondly, the temperature of outlet air should be low. So these are all automatically fixed. So that difference gives the maximum heating efficiency. Thirdly, outlet air should be used for heating inlet air. The air which is going out, that will have a temperature of at least 60-70 degrees Celsius. That air can be used for heating the inlet air, which will be cold at 20 or 30 degrees. So there is a better utilization of energy. And finally, inlet air taken from upper part. So the inlet air which is coming first at the top of the drying chamber, where it is having high temperature, and at that time the inlet milk, the spray, which will have a low temperature. So there will be very quick and fast heat exchange and quick drying of the droplets or particles. Here we can see the composition of milk powder prepared with spray drying. There are two categories. One is whole milk powder, which will have a moisture of 2%, fat 27.5%, protein 26.4, lactose 38.2, and ash 5.9. And in case of skim milk powder, the moisture 3%, fat 0.8%, protein 35.9%, lactose 52.3%, and ash 8%. Here we will see the PFA standards. This is the old standard. Actually, we have to see the FSSAI standard, which we will update later. So we can see the moisture content in case of whole milk powder, it should be less than 5, and both in case of skim milk powder also less than 5. The fat percent in whole milk, it should be minimum 26%, and SMP it is minimum 1.5%. Acidity less than 1.2 and 1.5%. Standard plate count less than 50,000 per gram in both the case. Coliform count less than 90 per gram in both the case. And solubility index in case of roller dried it is 15, and in case of spray dried it is 2. This is the same value in case of whole milk powder and skim milk powder. Here it is about the storage. The powder, it is having very minimum moisture. Even then the temperature should be less than 24 degrees Celsius. And for maximum storage life or keeping quality, the powder should be stored at vapor proof, moisture proof, and sealed package in a cool, dry place. So we are going to discuss little more about the packaging aspect. It should be totally impermeable to the moisture. And the yield. The yield depends on the fat percent in the raw milk and the SNF content in the milk and the moisture retention, how much level of moisture we want to keep. Depending on that, the yield will vary. Now we will discuss about the packaging. Of course, I am going to have a separate lecture on packaging of all milk and milk products. Here briefly we need to understand that any dried product should be packed with a packaging material or container which will have total moisture barrier. That means moisture should not go inside. That is called moisture vapor transmission rate, and also it will be totally free from gas entry. So preferably it should have minimum oxygen, and sometime nowadays it can be packed with gas flushing, that is the modified atmosphere packaging. In case of skim milk powder, nowadays for bulk the barrels are used, or glass jars are used, or drums or bags, bigger bags are used. For labeling, the name and type of the product, manufacturer with address, batch, date, weight, process, directions for use, composition, and the best before. All these details should be given. Nowadays there is a specific labeling details issued by the FSSAI. So all products should follow that guidelines for packaging. So now we are at the end of today's lecture. Today we have discussed about the dehydration or drying of milk. We have discussed the purpose and principle, the methods of drying, especially we have discussed more details about the drum drying and its procedure, technique, advantage and disadvantage. And next we have discussed in thorough details about the spray drying, which is the most common commercial method for large scale milk drying. And there we have discussed the details mechanism, the process flow, the mechanism in the commercial process, the infrastructure or the machineries involved, and there are different aspect of mechanism of drying and the collection of the powder, and finally about the storage and packaging and all such aspect, even the composition and standard. So this is briefly about the dehydration or drying of milk powder. Further details you can learn from my lecture notes or other books. Thank you.